Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. We are given an array and our task is to rotate this array by d places. So before we move on to the solution, let's first understand what is meant by left rotation. So we all have clock in our home and offices, and we know that how clock hand rotates. It rotates in this way, okay? So whenever we see any object rotating like this, we say that it is rotating clockwise direction, okay? But here in this problem, left rotation doesn't mean clockwise rotation. Here it refers to counterclockwise rotation. It means you have to rotate array like this, not like this, okay? You have to rotate like this. So let's say we have array, and in this array we have 5 elements, 1, 2, 3, 4, 5. And we are given that we have to rotate this array by d places, and the value of d is here 2, and here value of d is 2. It means we have to rotate this array by 2 places. Now how we rotate it? When we do rotations, our 3 moves at the position 1, 4 moves at the position 2, and 5 moves at the position 3, and 2 moves at the position 4, and 1 moves to the position 5. So this is how we rotate this array counterclockwise, okay? And after rotation, our array will become 3, 4, 5 and 2. So what we are doing basically, we are moving these 2 elements to the end, and we are moving these 3 elements to the beginning. So this is how it works. So when we rotate any array counterclockwise by d position, we get array and it looks like this, 3, 4, 5 and 2, okay? And here we are assuming that our d is less than n, okay? But what happens if we had got d greater than n? It means if n is 5, in this case what happens? See, if you rotate array by 5 places, then you get the exactly same array as the given array. So if we had got d is equal to 6, it means we have to basically rotate array by 6 minus 5 places, meaning only one place. So whenever we simply have to do d equal to d minus n to get the count of actual rotation, okay? So I hope now you have good understanding of this problem. So let's pause this video and think about an algorithm to solve this problem. Alright, I hope by now you would have written at least basic program to solve this problem. But let's see the brute force approach to solve this problem. So here is the idea. We have an array of 5 elements, and our task is to rotate this array by d places, and here d is equal to 2. So what we are going to do here, we simply going to rotate this array by 1 places 2 times. Alright, correct? Because d is 2, it means we can do like this, we can rotate array by 1 places 2 times. So it is equal to rotate array by 2 places. Now how we rotate array by 1 place? Let's see. So first we are going to store element at position 1 in temporary variable, okay? Then we are going to traverse this array from second element till n minus 1 element, okay? And while traversing, we are going to move each element before one position to its actual position, right? So let's say if 2 is at the position 1, we are going to move this 2 to one position before its actual position. It means 2 is going to move to this place and 3 is going to move to this place, so on and so forth. We have to follow this thing for all the elements from second element to n minus 1 element. So after we are done with all the traversing, we simply have to put this value stored in temporary variable to the last of the array. Okay, so what we did basically, we moved 2 to one position, 3 to second position, 4 to third position, and 5 to fourth position. And then we are simply copying the value stored in the temporary variable to the last one. So this is how we rotate the array by 1 place. Now, as d is given as 2 in the problem, so we have to repeat this process once again to rotate array by 2 places. So we again do the same process, and we get the array like this, and this is the array rotated by 2 places. So this is the basic idea of brute force approach. Now let's see the implementation of this approach. In this function, we are running loop from k equal to 0 to less than d. It means if d is equal to 2, then we are running loop for 0 and 1. It means 2 times we are running loop, because we want to rotate array 2 times, okay, by 1 place. And inside this loop, we are simply getting the length of the array by accessing the length property of the array class. And then we are storing value of first element in the temporary variable. And then we are running loop from second element till n minus 1. And in each iteration, we are moving all the elements one position before its actual position. Okay, and after all the shifting, we are again putting the value of temporary variable to the end of the array. This is how we get our rotated array, and we repeat the process 2 times to get our array rotated by 2 places. So now let's quickly dry run this code and see how it works. If we have array, and in this array we have 5 elements 1, 2, 3, 4, 5, and d is equal to 2. In first iteration, the value of temporary variable is 1, okay, and value of k is 0. So in this iteration, we move all the elements towards left and we put 1 at the last. So we get this array 2, 3, 4, 5, 1. Okay. In next iteration, the value of temporary variable is 2, because this time we are storing 2 in the temporary variable, right? And the k is equal to 1. So now we again repeat the same process, and this time we rotate numbers like this and move 2 to the last. So we get this array 3, 4, 5, 1, 2. So this is the final array rotated by 2 places, because 2 came here and 3, 4, 5 came here. Alright, talking about the time complexity of this function. So how many times outer loop is running? Outer loop is running exactly d times. And how many times inner loop is running? Inner loop is running 1 to n. It means approximate n times. So we can say that overall time complexity of this function is going to be theta of d into n. Correct? Okay. Now talking about the time complexity, as we can see that we are not using any auxiliary space to solve this problem. That's why the space complexity comes out to be theta of 1. It means constant space. So this approach is taking theta of dn time and theta of 1 space to solve this problem. But can we do it better? Can we reduce this time complexity to big of n? Think about it. Observe the given array and think about a solution that can solve this problem in big of n time. Why I am stressing on observation? Because observation is the key skill to solve any problem. So you must inculcate the habit of observation in yourself to solve any problem. Okay, moving on. So now let's talk about the efficient approach to solve this problem. And this efficient approach is based on some observation. So let's say we have an array and there are 5 elements in this array 1, 2, 3, 4, 5. And we are given that we have to rotate this array by d places and d is equal to 2. Alright. Now the output of this array after rotation is going to be like this 3, 4, 5, 1, 2. This is the output and this is our input. Now can we write this array in reverse order? Obviously. So let's write this array in reverse order. So it becomes 3, 4, 5, 1, 2. Now look at all the 3 arrays. Could you able to find any relationship between these 3 arrays? Look at this carefully and observe these 3 arrays. You can see that these 2 elements in this array is the reverse of these 2 elements, correct? And these 3 elements are the reverse of these 3 elements, and this is the relationship between these 2 arrays. And what is the relationship between these 2 arrays? You can see that this array is simply a reverse of this array. Do you got it? So it means if we rotate 2 elements and then we rotate these 3 elements, and then if we rotate entire array, then we get the output as expected. But what happens if we had got d is equal to 3? Let's see with d equal to 3. Now here we have 1, 2, 3, 4, 5. Let's reverse these 3 elements first. We get 3 to 1. Then reverse 4 and 5. We get 5 and 4. And now reverse this entire array. So we get 4, 5, 1, 1, 2, 3. It means it is working with d equal to 3 also. Means our approach is correct. So we are done. We just found the way to solve this problem in linear time. So this is the idea to solve this problem efficiently. First you have to reverse 2 items, means if d is equal to 2, we have to reverse 2 items and then we have to reverse remaining items. And after doing this step, we have to reverse the entire array. Alright, so this is the basic idea to solve this problem. First we have to rotate numbers or elements from 0 to d-1. Then we have to rotate all the elements from d to n-1. And finally we have to rotate elements from 0 to n-1. So after following these steps, hopefully we would get the output as expected. Now let's see the implementation of this efficient approach. Here we have a function rotate array, and this function is taking input as array and d. In the first statement we are getting the length of the array and reducing it by 1 because index starts from 0. So this index is 0, 1, 2, 3, 4. Okay. And then we are reversing the elements from 0 to d-1, and then we are reversing elements from d to n, and then we are reversing numbers from 0 to n. Okay. And this reverse array function is exactly same as we have discussed in the previous video. the video in which we have discussed how to reverse an array. So if you have not watched that video, then I highly recommend to watch that video. Come back here and continue watching this video. Okay, so let's quickly try run this code and see how it works. So we have array and there are 5 elements in this array. N is equal to 4 and n comes out to be 4 because there are 4 indexes here and d is 2. In first iteration, we reverse number from 0 to 1. So it becomes 2, 1, 3, 4, 5. Then we reverse elements from 2 to 4. Then we get 2, 1, 5, 4, 3. And then in the last step, we reverse all the elements from 0 to 4. So we get 3, 4, 5 and 2. And the output of this input comes out to be 3, 4, 5 and 2. And that is the final array rotated by 2 places. Alright, so far so clear. Now talking about the time complexity. The first function is going to run d times. Okay, because we are reversing d elements, 2 elements. The second function runs, in second function the loop runs n by d times because we are rotating remaining elements here, and then we are reversing all the elements. So in third function the loop is going to run n times. If we sum up all the time taken by function, then we get d plus n minus d plus n. Okay, if we d and d cancel out each other and we get 2n. So 2 is the lower order term. So in asymptotic analysis, we simply ignore lower order term and the coefficient of higher order term. So the time complexity of this solution comes out to be theta of n. Okay, talking about space complexity, we are not using any extra space. So the space complexity is going to be theta of 1. So we have successfully solved this problem in theta of n time and theta of 1 auxiliary space. So far so clear. Great. So before we end this video, let's have a quick recap of what we have done so far. So we are given an array and our task is to rotate that array by d places. To solve this problem, we saw the brute force approach. And what we did in brute force approach, we are rotating array by one place d times. So that is why the time complexity came out to be theta of dn. Okay. And after brute force approach, we saw the efficient approach to solve this problem. In this approach, we are reversing array from 0 to d and then from d to n. And then we are reversing array from 0 to n. This is the simple trick we have followed. And by using this simple trick, the time complexity came out to be big of n. And you can see there is a big difference between these two time complexity. It is theta of dn and it is just n. So we have reduced so many iterations here. Okay, so this is it for this video. Thanks for watching. See you in the next video.